Hey guys, welcome to the video for factoring special cases. We are in Unit 6. Our essential question is, what do we do when we have duplicate factors or when we're missing a term in our trinomial? Alright, so we're going to review some vocab from the previous set of notes, which is standard form of a quadratic. So standard form of a quadratic is ax squared plus bx plus c. Now you saw this for the first time when we learned how to factor trinomials. Now, we have to talk about what this really means, right? So remember that a quadratic, right, we learned this in Unit 2. A quadratic is the graph that has a U shape. And the highest exponent in a quadratic is the exponent 2. So for example, if I had the equation y equals 3x plus 2, I know that this is not a quadratic. This is a linear equation because when I would graph this, it would make a line. But if I wanted to make it quadratic, what makes something a quadratic is when you have the highest exponent being 2. So if I just tap on a 2 there, it all of a sudden becomes a quadratic. So I'll show you something. If I have 3x, let's just do y equals 3x. So y equals 3x plus 2, right? We graph this equation. It's a line. It should be a line. It's slope-intercept form. But notice that when I make an exponent of 2 here, it all of a sudden makes it a quadratic. So a quadratic is made simply by just adding an exponent of a 2 somewhere. Now, the standard form of a quadratic is super important because we need to be able to factor these things, and that's why we've been able to factor the trinomials. So if I look back at factoring trinomials, I'm able to factor problems like this because this is a quadratic. Our highest exponent here is a 2, so I can factor these things. Now, just to remind you that, remember, A, B, and C represent numbers. So A, B, and C represent numbers. Okay, so they're nothing more than actual numbers. So, for example, if we have example over here. Now, I'm going to mix this up, see if I throw this off. So, 5x minus 3x squared plus 7. Okay, now I want to be able to identify A, B, and C here for my standard form. Now, remember, standard form are your letters. So, not your letters. Standard form is ax squared plus bx plus c. Ax squared plus bx plus c. Now, this is standard form, right? So A is always attached to your x squared, B is always attached to the x, and C is always a number that's by itself. Before you can ever identify your A, B, and C, you must make sure that it's in standard form. Now remember, standard form of a polynomial is the highest exponent first and then going down. So that's why this is standard form of a quadratic. So it's a quadratic because of the 2 exponent. That's why it's a quadratic. But it's in standard form because you start off with the highest exponent, you go down to 1, and then you go down to an exponent of 0. So, before you can actually identify A, B, and C, you must ask yourself, is this in standard form? And the answer is no, it's not in standard form. So you have to rearrange it to make it into standard form. So standard form is the highest exponent first. So really this term should be coming first. So this would be negative 3x squared. The next term would be the 5x. Now this 5x is positive because if it was negative, they would put a negative sign. So it would be positive 5x. And then lastly, our positive 7. Now this is in standard form, and now I can identify A, B, and C. Our A value here is going to be negative 3, B value is 5, and C value is 7. So that's just kind of a review of standard form of a quadratic. All right, so we're going to factor the following completely. Now, this is strange because you're like, how do I factor this, right? So when we learned how to factor by grouping, right here. So when we did this, right, we did this by grouping because the whole purpose of it is I need to take something that is 3 terms and make it into something that's 4 terms because I can't factor by grouping unless I have 4 terms. So I have to take my 3-term trinomial or my 3-term polynomial, which is a trinomial, and turn it into 4 terms. But the problem is here I only have 2 terms. So you're like, well, how do I factor this, right? Well, before you do anything ever, you always check for a GCF, a greatest common factor. Now, if that greatest common factor is 1, then it's irrelevant, right? Dividing out of 1 doesn't really do anything. So I have 2 terms here. Let's check. What's the largest number I can divide out of both? It's a 1. Now, I can't divide on any x's because 36 doesn't have any x's. So my greatest common factor here is a 1 and nothing more. So that's kind of irrelevant at that point. Now, the problem is I only have 2 terms. I can't factor by grouping if I only have 2 terms. And I can't even use my AC method, right? So we've been learning the AC method, which is taking a trinomial and trying to split up and uncombine our like terms, right? That's the whole purpose of that. So what's wrong with this, right? So remember, standard form is ax squared plus bx plus c. And I want you to think about this. What term are we missing? Well, I have the x squared. That part is there. And this 36 is just a number by itself. So that's the C part, because C is always just a number by itself. I'm missing the regular X. I don't have an X here. So if it's missing, if it's not there, then what number is really there? It's really a 0. So I need to rewrite this so that the B is there. So this is going to be X squared. Remember, our B is missing, so this would be plus 0x minus 36. Remember, this is your ax squared, this is your C. We're missing the B, and our B here is a 0. So how many terms do we have now? We have 3 terms. Now, the only reason why I'm doing this, right, you can't do this with anything. For example, if I have 3x minus 2, I can't factor with grouping with this because this is not a quadratic, right? This is not possible to do because it's a quadratic. I mean, it's not a quadratic, it's a line, right? So the only reason why I'm able to factor is because this is a quadratic. So you check, is this a quadratic? Yes, because that exponent of 2 is there, which means I can technically simplify this somehow and factor it. So I plugged in my B, which is 0, and then I'm going to move on to my special cases. Now remember, we already checked for a greatest common factor, so we don't have to do anything beyond that. So I'm going to draw my X here. For my, what happened? Draw my X here for my AC method. Remember, AC goes on top and B goes on the bottom. So we're going to identify here. Now, I know for a fact that X squared is going to stay the same and negative 36 is going to stay the same, right? We know those are going to stay the same, but we're splitting that middle term. The whole reason why we do the AC method is to split that middle term up. Okay, so our A here, need to change back to blue. A, B, and C. So our A value here is, remember, be careful with that one, our A value here is technically a 1. It's the number in front of your X squared. So your A here is 1, your B is 0, careful with that, right? B is 0 here, and C is negative 36. Okay, so A times C, which is going to be 1 times negative 36, is going to give me negative 36, and your B value is 0 here. Okay, well, I need to think of 2 numbers that multiply to negative 36, but add to 0, right? So I'm going to list out a bunch of numbers. So I know negative 1 times 36. I know negative 36 times 1, right? So these are all combinations. 2 times negative 18. Let's do negative 2 times 18. I like to keep my negatives in the front. 2 times negative 18. Now you're like, well, do I have to make this list every single time? No. If you can figure out what those numbers are, then you're golden. Now, here's a trick for you. This was a special case. We had to add in that 0. They didn't write the 0 for us. We had to add that in. So if I want 2 numbers that multiply to negative 36 and add to 0, what's the only way 2 things can add to 0? Well, if they're the same number but opposite signs, right? So I know that in order for 2 numbers to add to be 0, they have to be the same number but opposite sign. So I know that negative 36, I got to think about it. Is there factors of 36 where they're the same number but opposite sign? Answer is yes, because negative 6 and positive 6 multiply to make negative 36, but they add to 0. So I'm going to go ahead and be like, oh, well, let's just skip, right? So I'm going to go ahead and list everything just in case. So negative 3 and then negative 12 times 3. Negative 4 times 9, negative 9 times 4. So you can see there's lots of combinations here. So negative 6 times 6 is our last one. So I believe that's all of them. Well, the one that matches or the one that adds up to what we need is that last one. Okay? But because you know this is a special case, you don't have to think about all these combinations. You'd be like, oh, automatically negative 6 and 6. Now again, if it takes you that whole list, it takes you that whole list. There's no rush. And it is what it is. Now remember from the previous notes, the order of this doesn't matter. So if you want to do positive 6 and then negative 6, that is also okay. So I'm going to do negative 6x and plus 6x. Now the reason why we're doing this is technically, have we changed anything? Does negative 6x plus 6x make 0x? Yeah, and it should, because all we're doing is uncombining the like terms. So you're not changing anything here. Now how many terms do we have? We have 4 terms, which means I can factor by grouping. So you split your terms into 2 groups. And I'm going to go pretty quickly through this section because this is review. So our greatest common factor is going to be 1x. We have x on the outside of the parentheses because that's where GCF goes. We have 1x left over, minus 6 because these x's cancel. And then you move over to your second set of parentheses over here. Your greatest common factor is positive 6, not a negative 6 because you only take out a negative if the first term is positive. So you took out a positive 6, so make sure you put plus 6 there. And you have left over x, because 6 divided by 6 is 1. Negative 36 divided by 6 is negative 6. Now, before you ever move on, you always check, do I have matching sets of parentheses? And you should. It should flow naturally. You should not force them to match. They should always match on their own. So what you do is you're going to take your two GCFs and you're going to put them into a set of parentheses. This is one of your factors. So x plus 6 is one of our factors. The other factor is you're going to put one set of the matching. So your other factor is x minus 6. And once you get to this step, we are done. Okay, so we are done with our factoring our special case here. So how could I check this, right? So if I wanted to check this, x plus 6 and x minus 6, right? How could I check this? Well, I could double distribute this back out. So I could do x times x here. I get x squared. X times negative 6 is negative 6x. And then do 6 times x, which is positive 6x. 6 times negative 6 is negative 36. Well, I notice that I have like terms here. What color should we use? Negative 6x and positive 6x, what happens here? Well, they cancel each other out. So that's a special case there because they end up canceling each other out. So we just have x squared minus 36. And that's exactly what we started with. So that's how we could check that. Okay, moving on to number 2. Now you're going to look at this and be like, well, what do you always do no matter what? You always check for a greatest common factor. And in this case, we do have a greatest common factor, and that greatest common factor is 4. So I need to factor that out. Now, our greatest common factor is 4. Does that 4 just go away into thin air? No. Your greatest common factor goes on the outside of your parentheses, and your leftovers go on the inside. So you have 16 divided by 4 is 4, and you have the x squared still. And again, you couldn't have factored out any x's because that 4 doesn't have any. And then you have negative 4 divided by 4, which is negative 1. Yes, you have to write the 1 there. You have to write the 1 there because there's nothing attached to it. The only time you don't have to write a 1 is if there's a variable there. There's no variable here, so you have to write the 1. Now, sometimes you can't keep going. So for example, if I have 3 and then I have x plus 2, right? If I factor this out and I get 3. Here, let me... there we go, right? Oops, going crazy. So right, we have our GCF of 3, so we take out the 3 and put on the outside, and then we end up with this, right? So here, I can't keep factoring, because x plus 2 is not a quadratic. Remember, what makes something a quadratic? It's that exponent of a 2. So you want to see if you can keep going if it's a quadratic. If it's a linear thing like this, you can't keep going. And this is linear because your highest exponent is a 1 here. So, is this a quadratic that's inside my parentheses here? Yes, so I can technically keep going. So I'm going to make a note to myself at the very bottom that my GCF was a positive 4. I factored out a positive 4 at the very beginning. Now, because I factored that out, I don't want to forget about it, but I'm going to pretend like it's not there for a second. Now, I can't factor by grouping or even use the AC method unless I have 3 terms. So I'm missing a term here, and I'm missing that b. Usually if you're missing a term, you're missing b. So I'm going to rewrite this, so it's going to be 4x squared plus 0x minus 1, because that b term is what is missing here. Now I know when I make this into 4 terms, because the only time you can use the AC method is if you have 3 terms. And right now we have 3 terms, so we can use it. So we know that that first term is going to stay the same, and the last term is going to stay the same, but that middle term, that 0x, needs to be uncombined. So we're going to draw our x over here for our AC method and identify a, b, and c. A here is positive 4, b here is 0, and c is negative 1. Okay, so I'm so sorry that there's so many loud cars near me. All right, so we do a times c. A times c here is going to be negative 4. Right, 4 times negative 1, and then your b here is 0. So you have to think about all the possible combinations that could multiply to make negative 4. Well, negative 1 times 4, negative 4 times 1, and negative 2 times positive 2. So these are the only combinations. But remember, this is a special case, right? Special case means, hey, there's something special about this, which usually, if there's a 0 here, you know that the 2 numbers that you have to add up have to be the same but opposite signs. So negative 2 and positive 2. Now, for sake of change, I'm going to do 2 and negative 2. Why not, right? So switch it around because it doesn't really matter. So positive 2 and negative 2. If I multiply those together, it makes negative 4, and then it adds to 0. So this is exactly what we need. So I'm going to put positive 2x and then minus 2x here. Okay, so moving on, once we get to this step, we can factor by grouping. You can only factor by grouping with 4 terms. So I split it into groups. So first group on the side here, I'm going to take out my GCF. The largest thing that can be taken out of both is 2x. My GCF goes on the outside of my parentheses, and my leftovers go on the inside. 4 divided by 2 is 2, and I have 1x left over. 2 divided 2 is positive 1. My x's cancel, so I have to write that 1 there because there is no variable attached. Move on to the second set of parentheses. The largest number that can go into both of these is 1. However, because this right here is a negative in the front, if I have a negative term for the first part of, oh my gosh, I can't speak. If my first term is negative, I must factor out a negative. So that has to be a negative 1. Okay? And then you open up your parentheses, put your leftovers in. Negative 2 divided by negative 1 is going to give me positive 2, and the x remains. And negative 1 divided by negative 1 is positive 1. So now I'm here. You check, do you have matching sets of parentheses? And we do, so we're all good there. I forgot what color I used for the second half. I used, the lavender color. Okay, so my first factor is going to be made up of my greatest common factors, my GCF. So 2x minus 1. Okay, so that's my 2 GCFs. And then you put your one set of matching factors next to it. So 2x plus 1 is your other factor. So one of your factors is 2x minus 1. The other factor is 2x plus 1. However, this is not your final answer because what else do we need? We need that 4 in the front, right? Now, I just want to bring this up again. Actually, I'll bring it up at the end. So you want that 4 in the front. So you don't want to forget that you have a greatest common factor of 4. So it's going to go on the outside of everything. So you have 2x minus 1. Oops. And then 2x plus 1. Okay, and then that's your final answer. So if you pull out a GCF at the very beginning, please don't forget about it. It's probably the most common mistakes when we do GCF stuff because we kind of just forget about it because we pull it out so early on and then we kind of just forget that it's there. Okay, so also if you decided to do negative 2 and positive 2 instead, you would end up with this as your answer, 4, and then 2x plus 1, 2x minus 1. So if you look at your two expressions here, they are exactly the same except the parentheses are switched around. But remember when we're multiplying, the order that we multiply things doesn't really matter, right? 3 times 4 is the same thing as 4 times 3. So the fact that the parentheses are switched around is still okay. So I have 3 factors here. 4 is a factor, 2x minus 1 is a factor, and then 2x plus 1 is a factor. So I have 3 factors going on. All right, moving on to number 3. Now, the first thing you should do is you always check to make sure it's in standard form, which I actually forgot to ask you on the first 2 because I'm just so used to getting into the zone of things. But you always want to make sure it's in standard form, right? If it's not in standard form, like we learned with the example, if it's not in standard form, I can't identify A, B, and C because it's not in the form that I need it to be in. So, is this in standard form? And the answer is, it is not. Because in order for it to be in standard form, you always start with the highest exponent first. So really, the negative 2x squared needs to be at the front, and then positive 32 on the second part. So you want to flip those around to make sure it's in standard form. Now, after you do that, then you can look for your greatest common factor. Now, do we have a greatest common factor here? And the answer is yes, we do. So you want to take it out if you have one. Now, your greatest common factor here is going to be 2, but because that first term is a negative, you have to take out a negative 2. So your negative 2 is going to go on the outside of your parentheses. And what you have left over, negative 2 divided by negative 2 cancels, it becomes 1. So you have 1x squared. That 1 isn't necessary, though, because you have that variable. Then positive 32 divided by negative 2 is negative 16. Okay, so in the inside, you have x squared minus 16. Now, can you keep going? Can you technically keep factoring? And the answer is yes, because you have a quadratic in here. Remember that 2 indicates that you have a quadratic, so that means you can keep going. You might have to do some little bit of readjusting. So I'm going to remind myself at the very end that I have a GCF that I took out that was negative 2, because right now I'm going to forget about it. Okay, well, I know that this is 2 terms, and in order for me to use the AC method, I have to have 3 terms. This is missing your B value. So we have x squared plus 0x minus 16. Okay, so I'm going to move this all over here, actually, because I ran out of room. I ran out of room during class for this, so I'm going to move this over here. All right, so we have x squared plus 0x minus 16. So I know that I need to use factor by grouping or AC method in order to make this into 4 terms to factor by grouping. So I'm going to draw my x here, right? Remember, AC goes on top, B goes on the bottom. So A here is going to be 1, B is 0, and C is negative 16. Now remember, you're looking at this new thing, you're pretending like that negative 2 is not there. When you're identifying A, B, and C, make sure it's in standard form, and make sure you're looking at what you have that's new. So A times C here is going to be negative 16, and B here is 0. And I gotta go do something real quick because it's gonna bother me because I'm gonna forget later. Okay. Now I gotta think of two numbers that multiply to negative 16 but add to 0. Now remember, this is special cases, so if you think about it, the only way for two numbers to add to 0 is they have to be the same but opposite. Well, I know that negative 4 and positive 4, if I multiply those together, it's going to give me negative 16. But if I add them, I get 0. So that's going to be our magic numbers. But again, if you have to list out numbers, then you have to list out numbers. And that it is what it is, right? There's no shame in that. Now, I'm going to go ahead and list them anyways, just so that we get some practice with this. So negative 2 and 8, negative 8 and positive 2, and negative 4 and 4. So, whoops. And I think I've done that for all of them so far. Yep. Okay, so we're going to rewrite this. Now we know that the first term always stays the same and the last term stays the same. Let me move everything up a little bit because we're going to run out of room. Because that happens, because I write huge, right? Okay, so we're going to split this up to be negative 4x and positive 4x, right? Negative 4x, positive 4x. Now remember, that's the equivalent to 0x, because if I do negative 4x plus 4x, I'm going to get 0x. So that's equivalent, and we're good there. All right, the next thing we do is we're going to split it into two groups. Okay, if we split it into two groups, then you factor by grouping. So, first group here, your greatest common factor here is going to be 1x. You can't take out anything larger than an x, so it's just going to be, it's just going to be x. So you have x that you're going to take out. And then you have 1x left over, 2 x's, you take away 1, you have 1 left. And then you have negative 4 left because your x's cancel each other. Then you move on to the second group. The largest number that you can take out of both is a positive 4, not a negative 4 because that first term is not negative. So this would be a positive 4. 4x divided by 4 is going to give me positive 1x. And then negative 16 divided by 4 is going to be negative 4. You always check to make sure your parentheses match, and they do, so we're good there. Now you're going to take your two GCFs and they go into a set of parentheses to become your first factor. So your first factor here is x plus 4. Your second factor here is x minus 4. But you don't want to forget that you took out a GCF at the very, very beginning. So you're going to have that negative 2 tacked onto the front there. So you have three factors. You have negative 2, x plus 4, and x minus 4. Uh-oh. I need to move this real quick because it is stuck to the other thing. I'm going crazy, you guys. I'm going crazy. All right, let me move everything over. It's going to bother me so much. All right, so moving on to number 4. So we have 3 problems left, so we're actually almost done. We're halfway through. Now, with this problem here, what do you always check for? Always make sure it's in standard form. Is it? Is it? It is in standard form, right? So it's already in standard form. Secondly, you always check for a greatest common factor. And you do not have one other than 1. 1 is the largest thing you can divide out. Now, this one doesn't have 2 terms. It has 3 terms. So can I proceed to AC method because I have 3 terms? Yes, you can proceed. Now, you know when you do AC method, the whole reason is that you're trying to uncombine the like terms of that middle term. You're trying to split this guy back up. So you know that 9x squared is going to stay the same and positive 4 is going to stay the same. So we're going to do A, B, C here. And then we're going to draw our x here for our AC method. AC on top, B on the bottom. Your A here is going to be positive 9, B is negative 12, and C is positive 4. So make sure you bring those signs with it as well. So if B is negative 12, make sure you put negative 12. So A times C here is going to be positive 36. And B here is negative 12. So I'm looking for 2 numbers that multiply to 36 but add to negative 12. And you're like, what does this have to do with the special case? The special case part doesn't come until the very end. So you're going to just perform it like you normally would. So you're trying to find factors that are going to multiply to 36 but add to negative 12. So 1 times 36, negative 1 times negative 36, negative 2 times 18. Negative 2 times negative 18, because you want to make it positive, right? 3 times 12, negative 3 times negative 12, 4 times 9, negative 4 times 9, negative 9, negative 6 times, 6 times 6, and then negative 6 times negative 6. All right, so these are all the factors. Now, again, it might not take you the whole list to figure it out. You might figure it out right away, but sometimes we got to do a list. Now, we wanted to add to negative 12. So out of all these combinations, only one of them adds to negative 12, and it's that last one. Negative 6 and negative 6. Those make negative 12 if I add them together. So they multiply to make positive 36, but add to make negative 12. So I'm going to have negative 6x and negative 6x. okay? Because we're trying to split up that middle term. That's the whole purpose of why we're doing this. All right, so once you have 4 terms, you can factor by grouping. So you split it into 2 groups, and we factor by grouping. So the largest factor that I can take out of both of these, the number is 3, and the most amount of x's is a single x. So outside your parentheses, you're going to have 3x, and on the inside is your leftovers. 9 divided by 3 is going to give me 3, and I have an x left over. So that simplifies 2 x's in the top divided by an xl. I have 1 x left. Negative 6 divided by 3 is going to be negative 2. 6 divided by 3 is 2, guys, and then x is cancel. All right, moving on to your second group. Okay, we're going to factor out the largest thing you can. The largest number you can take out is a 2. But because that 6 is a negative, because your first term is a negative, you must factor out a negative 2. So it's going to be negative 2. And then you have negative 6x divided by negative 2, so it's going to give you positive 3x. Negative 6 divided by negative 2 is positive 3. 4 divided by negative 2 is going to give me negative 2. Before you proceed, you always check to make sure your parentheses match, and they do. So you're going to do your first set of factors. So your first factor set is going to be 3x minus 2. So your first factor is 3x minus 2. And then your second factor is always going to be one of the matching sets, so 3x minus 2. Now, what do you notice about both sets of these parentheses? They're exactly the same thing. We have duplicate factors here. So I want you to think about something back in Unit 1. Remember from Unit 1. Okay, back in Unit 1, we had stuff that was like x plus 2 squared. And I told you that anytime you have that, if you have a binomial on the inside, you cannot distribute. What do we have to do? Remember, the 2 means you have to write it out twice, right? We'd have to write it out 2 times. So it'd be the exact same thing, but we'd have to write it out twice. But then we can double distribute, right? We can't double distribute till we write it out twice. So I have the same thing here. So what I need to do is I need to collapse them and combine them into one thing and make it 3x minus 2 squared, because it's the same thing. Okay, because they're the same. So we're really undoing everything. So back in Unit 1, we broke it up into 2 parts, and then we distributed, and then we got our polynomial. Well, here we're going backwards, right? So we have to go completely backwards and do everything backwards. All right, moving on to number 5. 2x squared y plus 4xy plus 2y. So you always check to make sure it's the standard form, and it is. Your highest exponent is first. But then once you do that, you always want to check for a greatest common factor. In this case, we do have a greatest common factor, so I want to divide it out of every term. The largest number I can take out of everything is a 2, but I can also factor out a y. Okay, so that 2y is going to go on the outside of my parentheses, and on the inside of my parentheses is my leftover. 2 divided by 2 is 1, so I know I have 1 there, and then I have x squared, and then these y's cancel. Now, whoops. Now I don't need that 1 because that x squared is there. And then 4 divided by 2 is going to give me positive 2. My x's stay and my y's cancel. And then I move on. 2 divided by 2 is positive 1, and my y's cancel. I have to have that 1 there because there is no variable attached to it, so I need that there. So because we had a greatest common factor, and I don't want it to distract us while we work the problem, I'm going to remind myself that my greatest common factor was 2y at the very beginning, but you don't want to forget about it. Now, because this is a trinomial, I can go ahead and do AC method. But remember, if you have something that's just 2 terms, you got to make sure you're going to add that third term in if it's a quadratic. Now, this is a quadratic. Remember, highest exponent is 2. So we can go ahead and do AC method. So we're going to identify A, B, and C. We're going to draw out our little X here to help visualize this. So AC on top and B on the bottom. Your A here is going to be positive 1, B is positive 2, and C is positive 1. So it's kind of strange, right? Remember, there's technically a 1 in front of that X squared. So A times C is 1. A times C is 1 times 1. And then your B is 2. So you got to think, right? What are all the numbers that multiply to make positive 1? Well, we have 2 combinations. Negative 1 times negative 1 make positive 1, or 1 times 1. Well, which one of these is going to add to positive 2, right? Sorry, I like to do my negative second for some reason. Well, which one of these adds to positive 2? Only one combination. So that means that my 1s are going to be on the sides here. Now, when I rewrite this trinomial into a polynomial of 4, this x squared is going to stay the same. I don't know why I always write it so far over. X squared is going to stay the same, and positive 1 is going to stay the same. But then your 2 middle terms are going to be positive 1x and positive 1x. Okay? Because you're splitting that 2x out. You're uncombining like terms. Once you have 4 terms, you can factor by grouping. So between your first 2 terms, your greatest common factor is a single 1x. I need to write a little bit smaller. 1 second. I need to shrink this. Move this up. Okay. and then move this down a little bit. All right, so your x is the largest thing you can take out. X squared divided by x is a single x, and then 1 is going to be positive 1 because 1 divided by 1 is 1, and then your x's cancel. So then you close your parentheses. Then the next thing you do here is you look at your greatest common factor between these. Well, the largest thing you can factor out is a 1, positive 1, so we put a plus 1 here. And then your 1's cancel. 1 divided by 1 is 1, so we have 1x, and then 1 divided by 1 is positive 1. Yes, you have to write it because there is no variable next to it. So before you move on, you always check, do you have matching sets of parentheses? And you do, so then you move on to the next step, which is you're going to make your factors. So your greatest common factors go together in a set of parentheses to make your first factor. So x plus 1 is our first factor. And then our next factor is going to be x plus 1, because that's the matching set. Whoops. X plus 1. But is this our final answer? No, because we have to tack on that 2y. But what else do we notice? We have duplicate factors. These are the exact same thing. So we have to rewrite this. Right, we have to rewrite this so that it's 2y and then x plus 1 squared. So the 2y is still going to be tacked onto the front because it was our greatest common factor. It still proceeds like normal, but we want to write that factor twice, or squared, because we had them twice. We don't want to write it out 2 times like that, so we want to condense it as much as possible. All right, we're moving on to our final problem, which is number 6, 4x squared minus 20xy plus 25y squared. Now here, you want to check for standard formula, like, well, how do I check that? That's so confusing. Now, this one is a little bit different, so standard form doesn't really apply because you have 2 variables going on. So when there's 2 variables involved, there isn't really a standard form, quote unquote. So we're going to kind of ignore that. We always like to keep the x squared in the front, so we're going to keep that in the front. Now, the next thing is, do I have a greatest common factor? Is there a number or a letter that I can factor out of every term? And the answer is no. I can't factor out a number or a letter out of this. So then I just proceed, right? There's 3 terms here. Can I make it into 4? Sure. So you're going to treat it just like normal, even though it's going to be a little uncomfortable. So you know for a fact that your 4x squared is going to stay exactly the same, and your positive 25y squared is going to stay exactly the same as well. Remember, your first term and your last term, they're going to stay the same. It's that middle term that's going to break up. So let's go ahead and identify A, B, and C on the side. A, B, and C. Draw our x here for AC method. A, C, and B. It's kind of big, huh? Let's rewrite that. A, C, and B. Okay, so our A here is going to be 4. Our B is negative 20, and our C is 25. Oops. Okay, so A times C here would be 4 times 25. That's going to give us 100. And B here is negative 20. Well, I got to think of 2 numbers that multiply to 100 but add to negative 20. Now, hopefully you can figure this out. Now I'm going to tell you it's negative 10 times negative 10. Negative 10 times negative 10 gives me a positive 100, but it also adds to negative 20. So I'm not going to list out all the possibilities here. So negative 10 and negative 10. So it's going to be negative 10xy minus 10xy. Now again, you're just copying what this is, because if I were to combine these, I should get negative 20xy. So it is a little strange, but just like how these, you have an x next to them because this has an x because you're splitting it apart, right? You're splitting these up. 1x plus 1x makes 2x. Negative 10xy and negative 10xy make negative 20xy. Now once you have 4 terms, you can proceed to factor by grouping. So I'm going to split this into 2 groups. Now your first group here, first group here, the largest number you can take out is a 2, and the most amount of x's is a single x. So you have 2x on the outside. Okay. Now 4x squared divided by 2x, so 4 divided by 2 is 2, and then you have an x left over. Negative 10 divided by 2 is negative 5, and then your x's cancel, but that y is still there. So you want to make sure you put that y there. Moving on to the second set of your group, or your second group. The largest number you can take out of both of these is a 5, but because that first term is negative, you must take out a negative 5. And I can also take out a y from both of these. Not an x, but a single y, because they have that in common. So negative 5y. Negative 10 divided by negative 5 is going to give me positive 2. That x is going to still be there because nothing went away, and then those y's cancel each other out. And then we have 25 divided by negative 5, which is negative 5. And then I'm going to have a single y left over. And before you move on, as always, you check to make sure your parentheses match. And they do. So 2x and negative 5y are going to be together in one set of parentheses to make the first factor. And the second factor is always your matching set. So 2x minus 5y. But again, I had this here for a special reason. It is a special case. Notice how your parentheses are exactly the same. So you want to simplify it even further and say that I have the same exact thing twice. Now, this is my final answer because I didn't have a greatest common factor. In number 5, we took up that 2y at the beginning, so that's why that 2y is tacked out there. But there was no greatest common factor for here, so we don't have one attached on the outside. So that is it for factoring special cases. If you have any questions, please